Hi everyone, I'm Anya. I handle business development at K-Mine. Before we dive in today into today's webinar, please remember to visit and follow our LinkedIn page. That's where we post all of our future announcements and upcoming streams. Huge thank you for everyone who is joining us today. Your support means everything to us. And also please meet our mining engineer, Vitaly, who is actually the author of today's webinar. Hi, Vitaly.
Yeah. Hello, everyone.
Vitaly will answer your questions in the end of the stream. So in today's webinar, we'll be focusing on the impact of road construction on mining projects. And let me start first by kind of like introducing our company. We initially established in 1994 in Ukraine. By 2024, we actually significantly expanded our reach. Today, you can find us in Europe, Asia, the United States, Canada. Our team is extensive and diverse, comprising developers, surveyors, qualified persons for NI 43 and JORC reports, and also like various mining engineers and geologists. We serve a wide range of clients with a cost-effective approach, from small exploration groups to large corporations. And our bread and butter is our software that we envision as a well-rounded space for the mining industry, guiding you through every step of your mining project, from exploration to full production. And it encompasses everything you need in 12 versatile models suitable for both open pit and underground mines. One of the reasons why we are suitable for small and large corporations is because you have the flexibility to choose the models that best fit your workflow. Whether you need just one or all 12, the software ensures ease of use with a single straightforward interface. These models handle tasks such as processing geological data, surveying, and developing optimized mining plans for both short and long-term projects. By connecting our software with IoT devices or dispatch systems, you can also monitor all these processes in real time, aiding in a quick, informed decision-making. So our software is born from real-world experience developed to tackle the challenges we faced in our consultancy work. It's designed to aid in the project evaluation, creating digital twins, and planning the entire life cycle of mine, making your job easier and more efficient. But our team is always ready to assist in creating 3D models, planning strategies, estimating resources and reserves. This isn't just an add-on, it's a part of our commitment to ensuring your success. Whether you're in exploration, development, or production phase, we're here to provide you this extra layer of support through our consultancy services. So if you're interested in learning more on what we offer and how we can assist you with your project, please reach out to us in the comment section. So let's take a look at our agenda today. We'll start with an introduction overview to set the stage. Then we'll cover the classification of road types and move into key aspects of in-pit road construction. Then we'll discuss the technical specification for pit roads and show you how to simplify road creation with K-Mine. We'll look at the effects of horizontal flat spots and economic impact of road infrastructure, and we'll also tackle common challenges and their solutions and wrap up with just final thoughts and conclusions. So feel free to share your questions and thoughts in the comments, and let's dive in. I'd like to start by talking about the importance of roads in mining operations. Think of roads as the vital connections between different parts of a mining site, like horizons or mine workings. The goal is to ensure these roads provide the quickest route between 2 points. This means they should be as straight as possible, have very few switchbacks, and maintain a consistent and optimal slope. Often these features are regulated by mining authorities. When you plan internal pit roads, it's essential to be thorough and consider stage. As the pit evolves, roads will need to be moved, and this process must be managed carefully to maintain access to all pits, elements, and communications. The way roads are laid out has significant impact on the project economics, and we'll delve into that more later. Now let's talk about different types of roads you'll find in and around quarries. We'll start with the internal quarry roads. These are the most critical since in large pits they cover the most ground and need a lot of attention to both design and maintenance. These roads have to be wide, just wide enough for the biggest vehicles to pass through. Plus, there are auxiliary roads for smaller vehicles and safety berms regulated by mining standards and usually overseen by surveyors or geotechnicians. Then we have roads on the surface of the pit. These roads connect the quarry to other parts of mining operation, like stockpiles, dumps, and factories. They're generally wider than the internal roads because they have more space to work with. So these roads need a strong rock base to handle heavy dump trucks and protective barriers like windrows or visible stakes that are often used to keep trucks on track. Lastly, let's talk about roads on dumps. Since dumps can be made of softer rock, the road base and surrounding area need to be reinforced with sturdy materials to support heavy equipment. These roads should be wide enough for the largest transport vehicles and comfortable to travel on. To access different dump tiers, we place horizontal inserts on the slope parts of these roads. Now let's talk about what a road for heavy-duty dump trucks should be made of. We've all seen the state of quarry roads, dump roads, and roads connecting them after a heavy rain. If there are large gaps in the road base between pieces of rock, rainwater will fill these gaps with a fine rock material, turning them into potholes. That's why it's very important to carefully construct roads for dump trucks. And road pavements for heavy dump trucks. And road pavements generally fall into two categories, those on weak, soft base and those on rocky base. Roads on soft foundations need a thicker layer of rock. Ideally, the thickness of each layer should be calculated based on the weight of the equipment used in the pit. If layers are too thin, then the road will fail. If they're too thick, it will result in unnecessary cost. So here you can see the most common rock size ranges used for building roads for heavy-duty dump trucks. Sometimes we determine the foundation thickness through trials and errors. Special attention should be given to the top layer, which directly contacts the tires. This layer must meet regulatory standards for parameters like flakiness, angularity, and wear resistance. For the best results, the top and final layer can be made from finely dispersed granite screenings cemented with a special liquid solutions. So this mixture fills all the voids and straightens the road surface. Maintaining these roads in good conditions is also essential using specialized equipment like graders, bulldozers, and loaders. Now let's talk about the key factors in road construction. First up is the width of the roadway, which could be which should match the size of the largest dump truck using it. Roads can be single lane or double lane. In tight spaces or when using roundabout, single lane roads can work, but they need clearance pockets every 300 meters or so. Shoulders are another solution. While not always used, they act as a buffer to ensure safe vehicle passage. If the roadway is wide enough, shoulders might not be necessary. The width can vary depending on whether the vehicles are loaded or empty. Now, let's discuss trenches. These are crucial, especially in wet conditions, for managing water, which is the destroyer of mining operations. The size of trenches depends on the type of rock, wider for soft rocks and narrower for hard ones. So they need regular maintenance and should be connected to sumps for effective water removal using a cascade system. Rock barriers can be made from soft or hard rocks, affecting their dimensions like the bottom width. The height of these barriers depend on the vehicles. So for heavier vehicles, it's typically half the wheel diameter. For smaller vehicles, like for those up to 40 tons, about 1/3 of the wheel diameter. The slope of the exit road is also a major economic factor. The longer road means more distance for transporting rock, means increasing costs. However, too steep of a slope reduces transport speed and efficiency. So we also need to consider the prism of possible collapse or sliding wedge. This ensures that no mining elements are placed within the potential collapse zone, which depends on the height of the ledge and the underlying rock. Lastly, the transverse slope of the roadway helps water flow of the road into the gutters. Other parameters can also come into the play, like power lines on transport berms. So next, let's talk about road profiles and different types you might encounter. The profile of the road largely depends on its location, whether it's on a dump, on a single-sided trench, double-sided trench, and so on. Each type has its own specific features. For example, when building a road on embankment, you need to construct a withrow on both sides of the road. If you have double-sided trench, this area is likely to flood, so you need to have trenches on both sides of the road, sometimes just one if the road has a single slope profile. If it's a standard road on a ledge, you'll have a drainage ditch on the side of overlying ledge and a barrier on the side of underlying ledge. This slide shows how possible parameters for roads used by heavy equipment for capacity of around 220 tons and the width of about 8 meters. It also illustrates various road profiles based on best practices used by BHP for vehicles with 220-ton capacity. Now, in a simple condition, let's look at an example of how a separate road is built in the K-mine environment. Let's assume that we have open pit and a dump. We need to build a road between them according to certain criteria. Such criteria may be road parameters and elevations. The road must fit into the situational plan of the area. To start the building, we need to draw a guideline which will serve as a formation guide for us. Next, we need to turn this line into the center line of the road. To do this, we use the road along center line command. We configure the necessary parameters and proceed to dynamically changing the construction parameters. Places where the specified radii do not fit will be indicatively marked in red. To correct the situation, we can change the radius of the road curvature and move the position of the point. In order to adapt our road in elevations, you need to use the Modify Stations menu, which is called up in the mode of dynamically changing the road by pressing the space button. Here you can change the elevation of each point, thereby tracking their compliance with the landscape. The changes are dynamic and all dependent parameters will be recalculated automatically, which makes it possible to control the construction at all stages. After confirming the changes, we return to the dynamic construction stage, and here by pressing the enter button, the desired center line will be created. Also, if added the necessary settings, we would receive band radii, a detailed report, coordinates of points, and other information. Next, we need a road profile. Using a snapping in the K-mine environment, we can create it quickly and efficiently. In this case, the functionality of K-mine is not inferior to any CAD programs. And then we'll use the create line by cross-section command, where we indicate the line type belonging to each profile point. To do this, we need to link our profile to the future construction. Since we will build from the central line, we will link to it. We indicate the appropriate type of lines for each of the profile vertices. At every step, the indication will tell us where we are, and then we understand what needs to be done. So once all the points have been identified, we can distribute the road profile of our center line. With a single click, we'll have a complete road ready to go. In this example, we used a road profile that contains 2 windrows and the roadway itself. Elevations correspond to given coordinates, and that's all. Ideally, of course, you can also build lines on the topography itself relative to the road to complete the picture, but these are already details that will not be difficult for an experienced designer to build. In the next video, we will show you clearly how projects on the final contours of the quarry are carried out automatically. Let's consider various project options. Also, our recent update made it possible to adapt the design contour to the existing topography. You can already test this functionality in the next version of our software, which is expected in July. As always, construction begins with determining the bottom of the quarry. Next, we create the necessary list of levels and begin construction. We assist the closed contour to a specific level and click calculate, and we'll get the contour of the quarry. This contour will be according to the list of levels without roads for now. We see that some of the wedge edges are above the topographic surface, which is good. And let's see how to take this into account when constructing the project. Let's add a road. And to do this, set the necessary parameters for the road and select the starting point. First, we'll build a project in which there will be no horizontal inserts. That will be our reference point, and we'll compare subsequent projects with it. Let's see what our project wireframe will look like. To do this, just activate the Display Project Wireframe checkbox. We see the topography is not yet taken into account. And in order for the project to be built in accordance with the topo, select the location of the situational plan in the layers of the active file and activate Adopt Project to Topography checkbox. So we see that our design lines have taken 2 forms. Those that will take part in the construction are solid. Those that are not lined, the design frame was also limited. After applying topography to the project, it's possible to visualize the line of intersection of the project and the After clicking the Combine Project and Topography Wireframe button, we get a project that takes topography into account. This is how, with the simple manipulations, the required result is achieved, which could take a lot of time to obtain when using the manual method. Now the project can be saved, and when loading it, you can build the baselines that take part in the construction. The next step is to build a similar quarry, but with the participation of horizontal inserts. For clarity, we assume that at each level there will be a horizontal insert 50 meters long. We will see how this will affect the project further. In the same way, we build a design frame taking into account the topography, give it different colors, and save it under a different name for further manipulations. And to build the third project, we'll take the top edge of the first option and apply the method of building a quarry from top to bottom with the participation of horizontal inserts. So to do this, we build the design lines and copy the required ones. Then we insert it in the original coordinate and begin the construction process. We also delete the previous supporting edge since the construction will now be from the top to bottom, and add the supporting edge for the highest elevation. This way, without horizontal inserts, we'll get a query identical to the query considered in the option number 1, but we will add horizontal inserts. As a result, we will get a completely different query with different economic indicators. This example is simple and is used to clearly demonstrate the difference and impact of the presence of horizontal insert as part of the road in a query. We apply topography to the project and build the design frame. Visually, we can track the difference between each of the options, and in any form, even in the form of a frame, even with the participation of design lines, the difference will be noticeable and visible. Next, we have to calculate the excavation volumes for each of the options, and to do this, we use the set property command with the block model active and limited to 2 frames, above the design one and below the actual one. This task is multifunctional and can be used both for block model and for other complex objects, for example, for working with a point cloud. We follow the sampling instructions step by step and determine the necessary layers in which our frames are located. After we see only that part of the block model that can be estimated, we begin to calculate volumes. By the way, we use the same method to manipulate the block model. We limit visibility of the blocks we want to work with and the set value functionality in the set properties command. To calculate volume using block model, we use calculate volumes and weight of block model command. We select an attribute for grouping and determine how quality attributes will be calculated and calculated. Data is easily exported to Excel for further manipulations, and let's do the same for other options and summarize the calculation results in one table. Now let's compare the results for all 3 options. As we agreed, option number 1 will be our main reference point. This first option gives us the lowest stripping ratio, the quickest access from the bottom of the quarry to the top, and covers the required volume of materials. Just to remind you, the first option involves construction from the bottom of the quarry without horizontal inserts. The second option also starts from the bottom but includes horizontal inserts, and the third option starts from the top of the quarry using the layout option number 1 but adds horizontal inserts. Now, the second option has higher stripping ratio and longer transportation distance, although the volume of ore removed stays the same. Specifically, we see a 12.5% increase in total waste, which translates to an additional 21 million tons, and a 45% increase in haulage distance, adding 1.5 kilometers. That's quite significant, especially when you think about the impact on every ton of rock mass removed from the mine. For the third option, we fall short by about 3 million tons of the required ore. This reduces the total removal from the quarry due to both ore and waste, as we can't reach the same level at the pit bottom. The stripping ratio goes up and the haulage distance increases by 900 meters. These differences will have varying impact depending on the specific conditions, but the larger query, the more noticeable this difference become. So now let's talk about how horizontal inserts affect visibility and potential consequences. When a heavy-duty dump truck or any other vehicle is moving up a slope, the driver can't see the section of the road that is higher up, just beyond the horizontal insert. This lack of visibility means driver can't see each other and increasing risk of collisions during maneuvers. Similarly, if there is an obstacle right beyond the horizontal insert, the driver might not have enough time to react and avoid an accident. However, if we maintain a constant slope angle, the drivers can have continuous visual control over the entire section of the road ahead. This allows them to see potential obstacles or oncoming vehicles well in advance, significantly reducing the risk of accidents. And now let's talk about the overall impact of horizontal inserts. One important thing to note is that when there are horizontal inserts on the ramp, vehicles have to constantly switch gears from the first to second. In contrast, on the constant slope, vehicles can maintain a steady speed in a second gear. Additionally, horizontal inserts increase the risk of rocks falling from the vehicle body when moving onto and off the sections. Horizontal inserts can also increase the cycle time for each vehicle, reducing their operational efficiency. And this leads to higher fuel costs, decreased gearbox lifespan, which is an expensive component to replace. The average speed of the vehicle drops and safety conditions worsen. As a result, more trucks are needed to move the same volume of rock, significantly increasing overall project costs. To sum up, horizontal inserts have a negative impact on both economically and in terms of safety. So I think we covered the topic of horizontal inserts thoroughly, so let's move on. Since we already touched on the topic of visibility, let's explore it further. This slide shows the conditions for designing the turning parts of a technological highway and different types of intersections, as well as key aspects of their formation. So let's break it down. First, any high vegetation that blocks the driver visibility along the road needs to be cleared to ensure maximum visibility. This is especially important when navigating curves on the main road. For intersections, it's best to avoid crossing more than two roads at a single point and to steer clear of Y-shaped intersections which do not meet at right angles. Ideally, the straight section of the road should be at least 30 meters on both sides of the intersection. To enhance safety, you can use a small windrow at the intersections, and it will serve as a visual guide for drivers. This helps them clearly see the area, and they need to navigate and avoid drifting into the oncoming lane. In summary, ensuring good visibility, giving drivers a clear sense of road dimensions, avoiding the intersection of more than two roads at one point are crucial for safe road design. Now, let's talk about windrows. These are crucial for guiding drivers and acting as barriers if vehicle loses control. Rock shafts are mandatory along the entire length of roads in the quarry or dumps. And on horizontal roads, they can be smaller since they mainly serve as guides. However, on exit ramps and near the underlying ledge, the rock shafts must be tall enough to stop moving dump truck. Rock shafts can also be used to guide and stop dump trucks when unloading from the dump tier. Before doing this, it's important to check with the geotechnicians to ensure the unloading area isn't in the prism of a possible collapse, which allows for safe unloading on a slope. Another important detail when constructing windrows is to include window that allow water to drain to the underlying elevations where it accumulates. Sometimes pipes are used to direct water flow to maintain the integrity of the slope. It's also common for windrows to serve as bases for power line supports. So in these cases, the rock shafts provide enough clearance for heavy-duty vehicles, especially when using low supports. In summary, windrows are essential for guiding vehicles, acting as barriers, ensuring proper water drainage, and sometimes serving as bases for power line supports. Now it's time to talk about switchbacks. Switchbacks can increase the haulage distance and reduce vehicle productivity because drivers need to slow down and to navigate the turns. They can introduce potential safety risk. So they also require extra stripping removal to access the mineral deposit because the pushback area gets reduced by the width of each road. However, they are sometimes necessary when the length of the pushback no longer allows for straight paths. When designing the turning area, it's important to place it on a horizontal intersection to ensure it has significant radius so the largest dump truck can maneuver without crossing into uncommon lane. To determine the required radius of the turning area, you can see the provided formula. And in summary, while switchbacks are sometimes unavoidable, proper design is essential to maintain efficiency and safety. So, since we already touched on the road safety, it's important to acknowledge that unfortunately, incidents in mining cannot be entirely eliminated. Our just goal is to minimize them to as much as possible. When using large equipment, blind spots become a significant concern. Each type of machinery has specific blind spots, and it's essential to understand and address them. Heavy vehicles and quarries have different sizes of blind spots, and it's crucial to recognize how these areas interact with other equipment. Being unaware of these potential dangers can lead to unforeseen incidents. So here's an example you might have seen before. It went viral some time ago, and it was used as a cautionary tale for novice drivers. Let's break it down to what happened here and why. In this incident, a driver of a passenger vehicle parked in the blind spot of a heavy-duty dump truck. Without warning, the truck driver, they continued to park, and the truck driver, not double-checking the area, collided with the passenger vehicle. Fortunately, there were no injuries, though the passenger car was irreparably damaged. And this type of situation is unfortunately common, often involving service organization members supervising repair work. The lesson here is to always be cautious and vigilant, be mindful and of blind spots, and always ensure safety before making any maneuvers. So next, let's discuss some of the biggest challenges of our internal quarry road present and how we can address them. Each of these issues can lead to serious consequences if not managed properly. First, road surface problems. The quality of the road material needs to be high to minimize tire cuts, increase the speed of heavy-duty vehicles, and reduce rolling resistance. Next, water in the quarry. We need a multi-stage approach to manage water, starting with in-well dewatering, followed by contour dewatering, and finally in-pit dewatering. It's crucial to minimize water flow into the quarry and control any that gets using trenches and sumps. And the next slide will show how water affects the wear of heavy-duty dump trucks tires. Ice is another challenge, though it's only a problem in certain areas. Ice can turn heavy-duty vehicles into uncontrollable hazards. To prevent this, we need to use additional reagent to dissolve snow and ice on the road. Some of this can be mixed into the top layer of the road, which is a justifiable expense. Fog is another issue. Many quarries stop working during foggy conditions, but there are solutions like installing specialized fog lights on power poles to guide vehicles. Ultimately, how to handle fog is up to the technological personnel managing the quarry. Dust can obstruct visibility and harm the respiratory health of employees. Combating dust is straightforward. Just irrigate the top layer of the roads and use reagent that absorb small rock particles, keeping them on the road surface. Potholes and humps are a common issue if the quality of the road surface component is not up to par. This can form. They need to be addressed promptly using specialized equipment. For humps, they should be cut off with a bulldozer. For potholes, they should be filled with a small crushed stone or gravel. Falling rock mass from vehicle bodies can also create obstacles. These need to be reported to the shift engineer and removed to avoid causing delays and forcing vehicles into oncoming lanes. Sometimes the transport berm can crumble, narrowing the roadway. In such cases, we need to widen the road by moving the side, or if that's not possible, ensure safe travel conditions with traffic control signs and priority passage rules. Sagging high voltage power cable is another hazard. They can be caught by the rock mass on passing vehicles, leading to wire breaks. Regular monitoring of overhead line support and clearances is necessary, and in the event of a break, notify the shift engineer and avoid the area until it's made safe with specialized equipment. Lastly, traffic rule violations often lead to problems and must be controlled by the shift engineer. Installing camera to monitor quarry operations and online can help with that. These are just some of the common challenges we face, and it's important to stay vigilant at all times. So now, as I promised, let's watch a video that demonstrates what happens to tires when they dry compared to when they encounter even a small amount of moisture. As you see, water significantly affects the integrity of the tires, and this example underscores how crucial is it to control water movement and keep mine workings in good condition. Now, as we wrap things up, let's summarize what we need to do to boost profitability through effective roadway management for heavy-duty vehicles. First, we need a well-designed plan that considers constant slopes, safe and minimal turns, and the shortest transportation distances. Building temporary ramps can help reduce transportation time and distance in the short term. And of course, we must adhere to safety rules during operation of heavy-duty vehicles. Next, it's crucial to stick to the design specifications when constructing the road. That means monitoring the quality of the materials used, ensuring the proper drainage from the roadway, and keeping an eye on traffic. Additionally, we should continuously monitor vehicle efficiency and take steps to improve it. By following these steps, we significantly enhance the profitability and safety of our operations. And on this slide, we want to clearly show how the quarry project impacts the efficiency of using road transport. So let's revisit our three project options and compare the main indicators. After some simple calculations, we see that the number of vehicles required to support one excavator ranges from 5 to 8 dump trucks. Now, consider that each additional dump truck costs over $4 million, plus maintenance, plus repairs and replacement of equipment. This significant cost difference arises from the specifics of the project design. Additionally, the lifespan of the gearbox and engine can be significantly extended by optimizing road design parameters. Volume management is also a major concern for company management. By improving the quality of design work, we can significantly reduce the amount of waste volume. Avoiding horizontal inserts, minimizing turns, and implementing all the strategies we discussed today allow us to save investments and redirect them towards more profitable areas. Finally, extending the mileage of the tire for heavy-duty vehicles is crucial, given that a single tire costs around $30,000. Consider how many tires each vehicle needs and how many vehicles we have in total. Effective water management will definitely increase their mileage. And in conclusion, I hope we been able to emphasize how crucial it is to focus on the quality of our roads. And by following best practices, we can improve our plant completion rates, free up dump trucks, and enhance safety during mining operations, and ultimately boost our profits through various savings. Now, let's see if we have any questions here, and let's bring our mining engineer Vitaly here. So, first question from the audience is what are the key things when designing a road at the beginning of the project?
Okay. Actually, so all our presentation is about key themes because all of them can't be covered. Then we just would like to highlight like main of them. But as mining engineer, I would like to say that in the beginning of mining project, you should take into consideration all of the possible aspects of this specific mine. So, for example, if it's a lot of water, so you should think about trenches, about the watering, as we talk about this. Then you should avoid the switchbacks in case if it's possible, of course. You should avoid also the horizontal intersections that we try to prove you during today's stream. Then it should be like a straight slope during hollow road. And what is the most important, I think, for mining engineer during construction of the road, it's um, the engineer should clearly see different mining phases. I mean, different pushbacks. So different pushbacks should connect it together with these roads. It shouldn't be any gaps because in this case, the mining will just stop.
Okay, we also have a question. What is the difference between ditches and trenches? Well, ditches primarily used for drainage and irrigation to create boundaries, and trenches often used for laying pipelines, cables, or they similar but not the same. Another question is how to work in a pit where there are no rocks, how to build roads there.
Okay, so in this case, I can see a couple of solutions. So first one is like easiest one, but the same way it's like the most expensive. It to define place where you can buy a rock. So you just buy it, then stockpile and use wherever you would like to. Then it will be um, 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 again when you will cover your soft material with rock mass, it could be extra dilution, so you should be careful. So not everywhere it's possible. So the second solution, it will be just to try avoid like whole big trucks, just to try to mine your pit with smaller trucks. They as a rule they require like less requirements for the construction of the road, so their pressure not so heavy. And I think the third one, it just try to reconsider. Maybe this transport scheme it's not that you're looking for. Probably it's better to use, for example, rotary excavators with conveyors and dumping machines. So it's just from the first point of view.
Oh, got it. And if, like, there was a question about horizontal inserts. So if they are so detrimental to the project, why do they even exist?
Yeah, it's something from our past. It should live on history. So I believe that previously our vehicle park was very restricted because of its parameters, because of its possibilities. So engines, the transmissions, and other important parts of the truck, it could be overloaded. And to unload this, it is necessary to move on like flat, straight insert. And during this moving, it will be unloaded. And
Can
what I would
we
like
can we
to
replace this horizontal insert with something else?
um,
Like
un- unfortunately,
just to navigate?
it's just requirement from the government sometimes. Sometimes people believe that it is necessary because of our parents make that and we will do this. You know, and what is really important here that modern dump trucks don't need any unload, and so they can move anytime, everywhere. They are absolutely new machines.
Got it. And what is the optimum road profile?
Um, okay, so probably at the beginning I should say that as wider road will be, as more expensive will be the mine because of um, extra stripping. The road will be wider, and we have to have like wider pushbacks to open the required amount of ore, and that's why it should be balanced. So actually, the mining it's always about the balance. But other way, it's not actually like single optimum. It should be like sustainable option for the specific conditions. So if we have watered areas, of course we need trenches. The windrows should be everywhere. Then safe distance between trucks when they are moving. Then uh, dishes or wider roadway, and of course sliding wedge, as we said, so like prism of possible collapse. So all of these parameters dictate us the minimum road widths. But I think also the most important thing here is roadway widths, because it's depend on width of the each truck.
Got it. All right, I think that's all the questions for today. Thank you guys so much for joining us today. Thank you, Vitaly, for creating this webinar. Please stay updated by following our LinkedIn page, and we'll see you next time. Bye.
Thank you. Goodbye.